Hello students, welcome to experiencetutor.com. Today we'll discuss class 12th chemistry relation solid state part 7. And here is the welcome message. Let us begin the lesson. In today's lesson, before we start with the new topic, let us see what we learned before. Let us recap in few sentences. So we have studied till now that three dimensions packing in CCP and HCP, two types of common voids are formed. In this, number of octahedral void present in lattice is equal to number of lattice point, and the number of tetrahedral void is twice the number of lattice point. So in the first case, as written here, that number of octahedral voids present in the lattice is equal to number of lattice point. Similarly, in a different case, in the tetrahedral case, the number of tetrahedral void present in the lattice is equal to twice the number of lattice point. Therefore, if the number of lattice point in case of octahedral void, if the number of lattice point is 4, the octahedral void will be 4. If the lattice point is 8, the octahedral void will be 8. But in case of tetrahedral void, if the number of lattice point is 4, the tetrahedral void will be 8, twice that of number of lattice point. Now position of tetrahedral void in CCP and FCC lattice. Let a unit cell is divided into 8 smaller cubes in which each cube has atom at alternate corner. It means that there are 4 atoms in each small cube which form a regular tetrahedron when joined together. In this tetrahedron there is a tetrahedral void. In the whole there are 8 tetrahedral voids in all the 8 tetrahedrons. Hence, we conclude that number of tetrahedral voids is double the number of lattice point. Now let us see the position of octahedral voids in CCP and FCC lattice. In a CCP or FCC lattice, there are lattice point occupied at the 8 corners and 6 faces centers. 6 face centers. At the body center of the cube, there is a point O which is not occupied. It is surrounded by 6 atoms on all the 6 face centers. At the joining, the face center on an octahedral is formed. Hence, it is an octahedral void. Simultaneously, there are 12 octahedral voids in 12 edges centers. Hence, we conclude that there are octahedral voids in 12 edge centers and 1 is at the body center. So, if we can write in summary, we can say that octahedral void in short form OV from 12 centers is equal to 1 upon 4 into 12, which is equal to 3. Octahedral void OV from body center is equal to 1. Total number of octahedral void per unit cell. Therefore, total number of octahedral voids per unit cell is equal to is equal to 4. By knowing this type of voids, location of the voids and fractions of occupied voids, we can determine the formula of a compound. In the next class we'll see, in the next slide we'll see how to solve numerical problems based on this concept. Here the problem is a solid is made of two elements X and Y. Atom X are in FCC arrangement and Y atom occupy all the octahedral sites and alternate tetrahedral sites. What is the formula of compound? So, atom of X forming FCC lattice means they occupy 8 corners and 6 faces, 6 face centers. Hence, the number of atoms. So, we can write like this. Atoms of X forming FCC lattice means they occupy 8 corners. Nurse and 6 face center. Six face centers. Hence, the number of atom is equal to, hence, the number of atoms is equal to 4. Just in the previous slide we have calculated it. Now we can write it tetrahedral. Tetrahedral sites is equal to 8. Number of Y atoms and number of Y atoms for octahedral sites is equal to 4. Number of Y atoms is equal to 4. Total number of Y atoms is equal to 4 plus 4, that is 8. Therefore, ratio of x is to y is equal to 4 is to 8, or if we can simplify it, then 1 is to 2. Hence, the formula of the compound is equal to x y 2. In the next question we have, in a solid, oxide ions are arranged in CCP. So here we need to correct it. It is not, it is CCP. 1/6 of the tetrahedral voids are occupied by the cations A, and 1/3 of the octahedral voids occupied by cations B. What is the formula of the compound? So we can write that number of oxide ions forming CCP is equal to 4. Why? Occupy 8 corners and 6 face center. And 6 face centers. Number of tetrahedral voids is equal to 8. Number of octahedral voids is equal to 4. Number of cations occupied tetrahedral voids. Number of cations occupying number of cations A number of cations A occupying tetrahedral voids is equal to 8 by 6. Number of cations B occupying octahedral voids is equal to 4 upon 3. Therefore, we can write A ratio B and O minus 2 is equal to 8 is to 6 is to 4 is to 3 is to 4, which is equal to, and a whole number we can write 8 8 24, which is equal to, in simplest form it will be 1 is to 1 is to 3. Therefore, the formula is equal to A BO3. Let us see our next problem. We will continue with this numerical problems based on these concepts in the next slide. Be with us in the slide number 8, solid state. And this is the end of today's topic. Please subscribe our channel and click on the bell icon to get notification whenever a new video is uploaded. Please give us a like sign if this video is helpful for you, and write a comment that what type of video you want, which lessons are difficult for you. We'll create a video and which will be absolutely free. Thank you for watching our video. Thank you.